Now, Year 8s, today we'll look at parallel lines and a traversal line. So, what on earth does that mean? So, sets of parallel lines are lines that are the same distance apart. So, you can see that these two lines here, this one and this one, okay, these two lines are parallel, and that means that this distance here is exactly the same as this distance here, which will be the same anywhere along the two parallel lines. Now, what is a traversal? A traversal line intersects with at an angle with sets of parallel lines. So this is an example of a traversal, and this is another example of a traversal. This is an example of a traversal. Okay, so these lines intersect with the set of parallel lines. So let's look at how this traversal intersects with a line. So the first one, we've done this one already. This is vertically opposite angles. And what we looked at the other day was vertically opposite angles are pairs of angles that are formed. Okay, they're opposite each other and they're equal in size and typically denoted with an X shape. Okay, so we can see here that we've got a line and another line intersecting with that line there. And so these two angles here are vertically opposite, and that means that if this angle, say, is 30 degrees, it's not to scale, then this one must be 36 degrees. Or, say for argument's sake, this angle here was 42 degrees, then this angle here will be 42 degrees because they're called vertically opposite angles. Okay, so that's the first one I wanted to review. Here's the first new one, and we call this relationship corresponding angles. So pairs of corresponding angles are both situated above or below the parallel line on the same side of the traversal line. Okay, so we can see here that we've got the parallel lines. Okay, so here's the parallel lines. Here's the traversal. Now the angles appear on the same side of the traversal. So here they're on the right hand side. And they're either above or below the parallel line. So we can see that it's below the parallel line. And what we need to know is corresponding angles are equal in size. So if this is 110 degrees, that means that this angle here must be 110 degrees. We typically remember corresponding angles with an F shape. Okay, and we can see here, here's a summary. So if this one is, say, let's go 100 degrees, then this one will also be 100 degrees because corresponding angles are equal in size. All right, the next one is the alternate angles. Okay, so alternate angles are pairs of angles which are both situated between inside the parallel lines. So we can see here the parallel lines, okay, and we can see that the angle is inside the parallel lines, not outside like here or here. And they're on alternate or opposite sides of the traversal line. So one's on one side and one's on the other side. And the thing to note is that alternate angles are equal in size. So here's an example. If this angle here is 37 degrees, then this angle here, by the rule of alternate angles, also must be 37 degrees. So alternate angles are associated with a Z shape, or I've even heard people refer to the alternate angles rule as the Z rule. All right, the final one that we'll explore is this one called co-interior. Okay, so where are they? Between the parallel lines, and they're also on the same side of the traversal line. Okay, so here we can see that the angles we're talking about are between the parallel lines, not outside of it, and they're on the same side of the traversal line. So we can see that these two are on the right side. All right, and they're supplementary or add to 180 degrees. So we heard the word supplementary the other day. They add up to 180 degrees. So that basically means that if I know this angle here is 80 degrees, then I know that this angle here must be 100 degrees. How did I know that? Because co-interior angles must add to 180 degrees. Usually we associate co-interior angles with a C shape, okay, which is helpful. when we talk about co-interior starting with a C. Alright, so let's do a few examples. So mark in an angle corresponding to the one shown. Okay, so what were corresponding angles? So that was co-interior, that was alternate, and corresponding. So they're either above or below, okay, and on the same side. Okay, so here we've got it on the left side, so it's going to be here. So it's going to be the situation where they're above. So these are corresponding to each other. Alright, here's the parallel line and here's the traversal. So our corresponding angle will be this one here. So these correspond to each other. Right, the final one, we've got the parallel lines here, angle here, so this is the corresponding angle. Alright, the alternate angle, follow the Z pattern. Alright, so if I know that that one is there, okay, the alternate angle, so they're both inside the parallel lines, has to be in this position here. Alright, here's this one here, so it has to be inside, so it's going to be on the alternate side, on that side there. Alright, here's the two parallel lines, so if one's there, the other one has to be there. Alright, I'm sure the last one will be co-interior, let's just see. Alright, so mark in an angle that's co-interior to the one shown. So this is inside, so it has to be inside, co-interior. Okay, those two together will add to 180 degrees. Alright, so we're on the same side of the traversal and they're both inside the parallel line. So here is the angle. Here's the two parallel lines, so this is where this angle must go. Alrighty, so let's do some examples and we'll go from fairly kind of, well, I wouldn't say easy, but we'll step you through sequentially, okay? So, find the value of the pronumerals in these diagrams stating reasons. Well, I'm not going to state the reasons, I'm just going to provide the value, okay? And you can take notes on whatever you found out. Okay, so the first one is I know that this angle here is 120 degrees. So this one here, B, must be also 120 degrees because I know that these are vertically opposite. I'm going to put down just VO. Okay, now if this angle here, B, is 120 degrees, that means that these two angles here, they're called co-interior, which means that this angle here, C, must, whatever it is, plus 120 has to equal 180. So C has to be 60 degrees. Alright, now we can get A one of two ways. What we can do is use the alternate angles rule. So I know that if this one is 120 degrees, then A must also equal 120 degrees. But I also know that because this is a straight line here, then these two have a supplementary relationship, okay? Which means that 120 plus 60 also needs to equal 180. So there's two ways to work out that that's 180. Alright, so yeah, we can use either. Alright, let's try this one here. Okay, so I can see here that I've got parallel lines, and what I find easy to do sometimes is just to extend them out a bit. Okay, so we can see that they're parallel lines. So I know that if this is 85, this angle here must be whatever is left over from 85 to get to 180 degrees. And that is going to be, what is it going to be? 95 degrees. Is that right? Yeah, 95 degrees. All right. Now I know that if that is 120 and that is 95, then I'm looking for this. And you notice that we're going around in a full revolution or a full circle. And that means that that has to be 360 degrees. Okay. So what I would do is to find out A, I would, from 360, remove 120 plus 95. And what's that going to be? 210, 215, 85, 145, I think. Okay, so I might just use a calculator on that one. Now just use the CAS calculator. It's the same thing, 360 take away 120 plus 95. Yep, got that right, fluke. Okay, now let's do this one here. So we can see that this is a parallelogram. Okay, so what we'll do is just extend that out like so. Alright, so we can see here that these are parallel lines and these are co-interior. Okay, so because they're co-interior, that means that that and that need to add to 180 degrees. So this is going to be 108 degrees because 72 plus 108 is 180. Alrighty, so what we'll do now is we'll get this angle here, even though it's not telling us to. Okay, we'll get it anyway. Now, if I know that this is 108 degrees, these two lines are also parallel to each other. Okay, so they must have a co-interior relationship. Okay, which means that this one has to be 72 degrees because those two have to equal 180. Finally, I know that these two have to equal 180, so this one must be 108 degrees. And you can see that for parallelograms, that angles opposite each other are the same. Alright, let's do this final one here. So this is a tougher one. Find angle AOB. AOB. So we want this angle here, I presume. Could be this outer angle here, I'm not sure. But go the inside angle. So I know that this one here is 116 degrees. Okay, so what I'm going to do is just extend this line out here. And if this is 116, then this angle here is co-interior with 116. So this must be 4 to 20. This must be 64 degrees. Alright, now I can see here that what I've got, I'm just going to get my highlighter. This thing here, this is a triangle. And the internal angles of a triangle always add to 180 degrees. So that means that if I know this one and I can get this one, then I'll be able to find out what this angle here is. And if I can find out what this angle here is, then I can get this one. Alright, so let's just chip away at this. Now I know that this is 147. We're on a straight angle here, which means that I need to get to 180 from 147. So that's going to be 33 degrees. Okay, so I'm just doing this mentally. You guys feel free to use the calculator. Alright, now let's get this angle here. Okay, so I know that 64 and 33 equal 97. That means that this angle here from 97 to get to 180 is going to be 83 degrees. Finally, okay, I know that these are on a straight angle here, which means if this is 83, this must be whatever 83 is added to get to 180. So that's going to be 90, what is it? 97 degrees. So angle AOB is 97 degrees. Alright, so there's some pretty tough examples there. Get started on the worksheet and yeah, hopefully you go well.